Okay. So welcome everybody. Welcome to this second lesson about NetLogo. And so first of all, do you have some questions about the last lesson, or have you thought about some model to develop? I received a suggestion on how to model an irrigation system for managing some plantation. But okay, maybe we can try to implement this, but maybe in the future, because I think we need some more sophisticated tool. So, do you have some hint on what you would like to see? Otherwise, I proceed. So, okay, in any case, you can interrupt me when you want. So we have seen essentially how to model things using patches. And this time I would like to present you something about using turtles. So one possibility. So first of all, let's start with say a simple say modeling as we saw last times. For instance, the trajectory of a particle thrown in the air. So say we have this, as always, the setup. Then we may need, say, some slider that is, for instance, the initial velocity of our projectile. Then we set the scale. For the moment, just put it like this. Maybe another slide is the angle. Then we try to use mouse for setting these things. But for the moment, just put these two sliders, and then there is a fire command. So we shall start, say, in a very simple way. I want to put here a cannon, then throw my projectile using this initial velocity and this angle, and maybe record the width of the trajectory. Buon pomeriggio. So the jetty, essentially. Is there anybody wanting to enter? No? Okay, so let us start, say, drawing a kind of cannon, just for showing another thing. So there is a turtle shape editor, which can be used to draw something. And since we don't have here a cannon, I think, ciao Sara, I think we can try to draw a cannon from scratch. Okay, so new, so we can have a look on how this works. So the editor is quite simple. You have these shapes, so essentially a square or a circle or some arbitrary shape. And my idea is to try to design a kind of cannon, say something like this. Then we may add something, I don't know. No, I don't want to do something very complex. So you can try to do it by yourself. So you see that you can change the shape of things that you have drawn into your system. So let us start with a cannon in the horizontal position. So maybe this is the main part. Let me put it in the middle so that when I
Excuse me, how did you open this window again? I
okay, you
don't
go.
remember.
Yes, sure. Let me just save this cannon.
Yeah, sure.
So you go to Tools, Turtle Shapes Editor, and then you should see this. Tell me if it is okay.
Yes.
So maybe a smaller one, and then I can add a wheel just for showing something. So I may add here a wheel like this, or maybe larger. I don't know. It is an ancient cannon, this one. Then say you can duplicate. Unfortunately, it is rather say simple and not very complex, so you cannot do a lot of things. So you have to arrange yourself up with shapes. For instance, you can use this to mark the difference between it's not willing to collaborate. Okay, let me see. Like this. Then you can add also the center, but in order to do things simpler, I finish like this. So you see that essentially you have the to choose among these colors, and you can choose one of these color that may change when you add some command. So the color. Then you see how it behaves when you rotate. So if you, for instance, here I think it is better to move everything so that the center of the wheel is in the middle. Like if I manage to arrive, maybe like this, so that it looks better when you rotate it. But clearly this is just a matter of taste. This could be larger. We could do, say, some funny shape cannon like this. So essentially you can do whatever you want. So suppose that this is okay for you. So I name it cannon, and now I can use it. So I open the code here, and so to set up, clear all, create create a turtles one, set shape cannon, set color, I don't know, white, and then I put it in some position. So I think it is better if we use this corner as a 0, and so set x, y, I don't know, 2, and set the size, I don't know, 2, for instance, just to have a look, and set exit. Okay. So here I create a cannon, and then clearly I have also to set heading, say 45. so that it starts in a certain position. Actually, the heading here, Canon, the heading is toward the north. So essentially, I could have drawn this, say, flipped of 90 degree if I want to use just the heading to head the direction of the cannon, or I can say that this one minus 90. And in this case, 45 for me is an inclination with respect to the ground. Okay, maybe I may want to make a drawing here just to say mark the position of the ground. So I may say ask all patches below a certain height to become, I don't know, yellow. Quindi ask patches with white core less than, say, 2, set p color yellow. With p white core. Okay, so more or less this is what I was thinking to. Is it okay for the moment?
Yes.
Maybe we could say draw the. Okay, thank you. So now to go to fire, because this is a fire. I can say first of all set ask turtle. So ask this turtle. Now there is a point that I would like to introduce. So in many cases you have several type of turtles. Maybe in this case we have the cannon and the projectile. Clearly, I want to be able to address either one or more cannons and one or more projectiles separately. So the interesting thing is that I can define a kind of object that in this language are called a breed, so a species essentially. So I can create a breed cannons cannon. I have to provide the plural and the singular version of my breed, because here I can create cannons, one or more than one, and then I can say I may use just one cannon. Say, for instance, ask a cannon number 1 and so on. Okay. So in this case, in this way, I can create maybe another breed like balls or projectiles, and then I can separately address to cannons or to projectiles. So for the moment, just try to move the cannon. So to fire, ask cannons, set heading, say angle minus 90. Then I make this fire forever. And when I click fire and I move, something is not working very much. Ask because I had not repeated the setup. So in this case, I can move, you see, my cannon, maybe I can make it larger, set size, say 4. Okay, and then maybe less than 1. Okay, something like this. So that you can see better that now I can say variate the inclination of my cannon. Then I shall try to do the same with my mouse, but for the moment, just use this. And then, so maybe this is not fire, but so okay. Maybe we can use the click to make to start the projectile. But for the moment, let's do it with another button. So maybe this is the real fire, and this is tipo aim. To fire. Now, when I choose a fire, I have to create another projectile in a correct position. Then we shall arrange this, and then iterate the law of motion until it hits the ground. So to fire, I can say ask buonasera, ask cannons. Allora, when the observer create something, it uses the keyword create a certain breed. If a turtle is creating another turtle, the language is that of say animals, so it hatch balls one. So this means that a turtle can create another turtle, maybe of different species, duplicating its position. So the new hatched ball set shape circle, set color green, and then I have to assign this some. So it has a certain coordinate. So set x, y. Say the coordinates of who is creating this. So is x core. Now I shall explain. X core of myself, y core of myself. Now I shall explain what is here. Let me put it slightly bigger. For the moment, let's just do this. So fire, it creates a ball there. So let's examine this, essentially these things. So off, the operator off takes an agent set here and apply a reporter, something that returns a value, and returns this. So for instance, let me try just by hand. So create turtles, say 10, just set xy random x core random y core. So in this case, just for trying, I create 10 turtles at random somewhere. Then if I ask to show x core of turtles, it gives me a list of the x coordinates of all turtles that are here, because turtles is an agent list. xcore is applied to each item of this agent list and returns the x position. So show xcore of balls. It gives me a list of just one item, because there is only one ball which has a position, x position in equal to 2. Okay, so this is how this off works. Myself is a special agent set, which is the agent set formed by who is asking to do something. So essentially, this myself is the canon who is creating the balls. So it's a, otherwise, clearly, I could have done define a variable let x myself. Well, okay, it's essentially the same myself, and then here put x, but it's essentially the same. Okay. Okay. So this is fire. So now with fire, maybe I can put the ball smaller, set the size, I don't know, 0.5. Clearly, now we have to correct the position, but for the moment, let's just put it from here. Then we can say create this maybe here. And now I have to iterate something. Let's define a procedure to, I don't know, step. This is a procedure for balls. So essentially, the law of motion the equation of motion is the xcore goes. Maybe you remember from the high school. No, the x is going in a uniform motion, while the y is accelerated. The first goes up, so first decreases the velocity and then increases in the negative sense. So we have to define something, because I cannot just iterate only using the x and y coordinates. I need also the velocities. And this is another aspect that I would like to introduce, is the variables that, for instance, all ball have to can use. So I can write the balls on, and here a list of variables. For instance, Vx, Vy, and I also write x and y, even though they are equal to the coordinates, because I want to. In this case, I don't need it really, but in sometimes I need to go away from the world. And if you try to move a turtle away from the world, it gives you an error. So in some cases, you may need to pre-calculate the coordinates and then to say, okay, if these coordinates are outside the world, then stop the simulation. So I may need also some globals. For instance, the unit, the interval of time, set dt, I don't know, 0.1, maybe the gravity force, set g minus 1, then we shall arrange all this. And okay, maybe also reset ticks so that it starts counting. Yes? Sì? Grazie. Okay. So, so to step, the idea is that this is for the technicalities, is a leapfrog integrator, but it is a sufficiently simple and accurate way of integrating the law of motion of an object. So set x, let me first increase, okay, set x plus vx times dt, set y plus vy times dt, then set x, okay, set vx the same, so I don't need to increase to change vx. Set vy minus g times dt. So essentially, this is just a step. And so let me set up set x core, set y core, set vx, and it will be v0 times the cosine of the angle 64 minus 90, which is now the inclination, the angle with respect to the horizontal line. Set vy v0 times the sinus 64 angle of angle minus 90. Okay, and then I can iterate while y greater than this ground, or for instance, okay, for instance, let's say greater than 1. Ask cannons step, balls step, and then we okay, and here we can set x core x, set y core y, and maybe something is happening. Let fire, there is some error. To fire while I don't see the error. Why it is not? You can't use because fire is a turtle only. Ask cannons hatch ball 1. So this is a cannon. While ask ball steps. Okay, so the problem is here. Because while, okay, because y, the problem is that y is a variable that belongs to ball, so I cannot actually access this variable here. So let me do another thing. While true, and I put the condition here. If y less than 1, stop. I'm not sure it is working. So let's define. Now let's do something. So let's define a variable here. Okay, stop question point. So I set stop true while stop set stop false. So let me explain this. So the first, I couldn't do what I tried because y is a variable that belongs to balls. So I cannot access this. I cannot use simply stop because stop is for stopping a button that is marked forever, not for stopping just a procedure, at least I think. So a way of say achieving the same result is to define a variable, set it true, go on until this becomes false, and put the condition here. The balls advances, and if it is below 1, it set this variable stop, so that then should exit this loop. So something still is not really fire is because I have put it in the wrong place. Stop should stay among the globals. Okay, so set up aim fire. Okay, let me create the ball with the pen down so that we can see the trajectory. Okay, this is really not what I want, but maybe it is just because I use a time interval too large, or because V0 is too large. Let me change this. Now it is too small. Here I have to decide either I put a minus here or I define G negative, otherwise it accelerates towards the high. So let me put like this. I would like to remove boundary conditions. And now let's see what happens. Is now I have to increase the maximum velocity. Something not really working. The angle is pointing down. Yes, but let me see. Canon 0 has heading 315. Why? Angle should be this one, no? And this is the angle from, so I have to, if I want the angle be, yes, so we have to change the conversion of angle. So it is just a -1 times angle. Let me, so angle is now is a 55. So here, no, here should be 90 minus angle, no? 90 minus angle. If I want to use the coordinates from here, the horizontal, so that now it is 90, and when is like 90, it is horizontal. pattern, something. Okay, now something happened. Maybe it is too large. Let's start with okay, less initial velocity. Now something starts to work. Then clearly we have to correct for the initial position, but so instead of x core, it will be since a heading is a direction perpendicular to my cannon. Okay, but here maybe I would like to have a angle, the right angle, so from the beginning. So let do the opposite. So I'm is 90 minus angle, and this should be just angle. Let me see if now it works. So now when this is no, so 0 should be 0 should be 0. No, it is simply angle in this case. So 0 now is 0. Yes, but I want to go in the opposite direction. So it is minus angle minus 1 times angle. Let's try this. So aim. So this is 0. Okay, now I use an angle which is more sensible. Okay, so we can now say correct this misbehavior here, for instance. So when I create the ball, I have to move x core and y core in the direction of the heading. So x, which is here, should be reduced by minus size divided by 2 times some sinus. So when it is angle 0, okay, here I have to comment, otherwise I cannot see. So when angle is 0, I have to increase of 0. So I think it is a sinus of angle. And the y core plus something like this one, cosine of angle. Not exactly. X core should be okay, because this is size of the ball. I have to use the size of myself because it is the size of the cannon. Let me see if now this is not so bad. The problem is that now I have because first I have to aim and then to fire. Okay, not so bad, but something is still wrong. Okay, because the y, the x is okay. The y is this. I'm not seeing my error. There should be somewhere. So let me just comment this. When you want to comment something, it is somewhere, should be a suggestion here. It is command semicolon or control semicolon. Okay, I don't see it. Okay, so now when I put fire, this is not. Okay. The problem is that I have to see something. I have to do this. So it is moving to almost in the right direction, but not quite. So because probably it's not. This is not just a half. So maybe it is some fourth side. Because when we draw the cannon, it is not going to the top of the space available. Now this is almost good. Then I could move all of them plus in this direction for a certain, say, this is yes. Tell me.
Prof, posso fare una domanda? Ma il simbolo vicino a aim in basso sul bottone, che cosa?
Questo è, it simply remembers that it is a forever button.
Ok.
So which is a button which is pressed forever until I deselect or until I make a stop here.
Ok.
Ok. Okay, so this is just
Prof, ho provato a scrivere il codice, ma non va.
I arrive, just a moment.
Okay.
Plus, say, 1/2. Let me see, just this is an aesthetic. Cosine of angle. And here something similar, 1/4 cosine of angle. Y also plus. No, this is minus 1/4 plus 1/2 times sinus of angle. Let me set up aim somewhere. Something which is not times. Okay, so now this should work also with this. Check. Okay, let me see. Something wrong. So I moved in the right position before setup. Fire. So again, too much because I have minus 1/4. So this worked, no? No, this is the because minus is here. Okay. Okay, so now this moves in the right position, and then if I add this part, okay, now is almost in the right position, almost. Maybe I have to variate a bit these numbers. This should be in the right. Oh, okay. I have first to move. Okay, now it should work. Set x core, set y core, and now I can decomment this, and now it should work in the good way. Okay. Why is it not? Because set stop false. Set stop true. Just to be consistent. Okay, so now it is not working for some reason. It essentially, the problem is this: set stop false while not stop. Okay, now this is too much, but this is okay. And if I fire again, okay, I have to. The idea is that set the stop true, and then I make the ball die, so that I only have one ball, and now I can fire several times. Okay, so which was the question, the problem? I shall save this in the shared directory, so that if you want, you can load it. So somebody had problems. No, solved. Okay. Other questions, suggestions on this problem? Maybe we can do the field larger, so that we can comments. Everything is clear.
Prof, a me dicevo non va, cioè non si inclina il cannone nemmeno, però...
When you select aim,
ok.
Does it stay selected or not?
Selected.
So the problem is here. This should be.
Ok.
Just start with this heading, so that it also without aim, it already stays in the right direction. If you try to write this, is it working or not?
Ok, I try.
Wait
a moment. 1 to aim. Prof, può salire un attimo sopra col codice nel setup?
Yeah, sure. Just a minute.
Ok.
It is saved in the shared directory. If you want, you can just...
Ok. Lo verificherò nella diretta.
No, but let me
Nella
see.
diretta.
Maybe I have to change something in the permission because I don't see it in the shared directory. Let me see. Yes. I have to. It is another shared directory because it is another account. So save as, not here, but here. My drive. Some teaching something. Teaching introduction, and here is okay. Now you should see it in the shared directory. Maybe it may take some. Okay, now you also have it in the shared directory. Okay, questions, other problems, or maybe still you, Vincenzo? Okay, so now the next point is to say, instead of using these two buttons, let's try with to use the mouse. So I want to and fire, which is a forever button. So the idea is that when I press this, I would like to use the mouse to make the cannon turn and the click to make the cannon fire. So to aim and click, the idea is that I have two variables which are mouse x core and mouse y core, which are the coordinates of my mouse in the window with the coordinates of the window. So essentially I have to set angle atan the mouse y core, mouse x core, and then aim. Let me see if this works. Something is wrong. Aim and fire. No, aim and click. Aim and fire. This is another thing. Aim and fire. Okay. So aim and fire. You see that I can now move the angle by moving the mouse. I can also say set V0, the distance from the cannon. Set V0, let me define two auxiliary variable. Let delta x mouse x core minus x core of one of cannons. So you see that I want to compute the distance in the x and then in the y of say my coordinates of my mouse and the coordinates of a turtle, an agent. So I have to ask which agent. Clearly, I only have one cannon, so I could say store somewhere the ID of this cannon. Remember that each agent has a unique ID. Let me comment this, otherwise So if I inspect Canon 0, 0 is the ID. So I could say, just say Xcore of Canon 0. But since I only have one Canon, Canons is the list, the agent set of all Canons. One of is a random one, but since I have just one of them, I can use this or simply Canon 0. The problem of using Canon 0 is that the ID is computed sequentially for all kind of agents. So if I create some other agents here, create turtles one, just to create it, create turtles. So now I create a turtle somewhere, and this is Canon 1, no more Canon 0. So if you want to be independent of the order of creation, it is better either you define a global variables that stores the ID of this canon, or if you are sure that you only have one canon, you can use this trick of saying give me that of one canon, and this should work. Then this square t of delta x square plus delta y square, and probably we have to scale it. Let me check. Set up a. So you see that probably we can say divide it by 2, for instance, or by 10, just to have some sensible range here, or just scale the velocity. Yeah? So maybe this could be, say, divided by 4, just to be. So now it is something more sensible. And then if mouse click fire. So let me see. If mouse down, if mouse down, if the button of the mouse is down, I call fire. So let me see. Okay, so now it is much more usable. Clearly, we still have to say not to use this, and this is done to step if y stop to or x greater of max px core. So now we should also deal with say buttons that go too far. Okay, so you see that it is better to start with buttons, and then maybe you can add some way of say using the mouse. So questions? Can you have you? I was probably I was too quick, but I wanted to be sure to finish this example before the end of the lesson, and maybe have time to do something more. So let me know if you understood the ideas. If you have questions, if you want to see more in detail some of the aspects of this language. No, everything is clear. Okay, so now we could do either add. How easy to generalize this to more complicated motions? Okay, so let's try with the more complex motion. Say the Bertrand problem. The Bertrand theorem is interesting. So that the theorem states that if I have a body which is attracted to a center of, say, let me explain it on the blackboard there, maybe you can see it. So the Bertrand problem, I think it was formulated in the 18th century. The problem is this one. You know that if I have here the sun and here the earth, and it has a certain initial velocity, it makes some ellipses, maybe this one or this one or a larger one, around with the sun in the focus of the ellipses. This is the Kepler first law. But instead, so this is with a force. This is the distance. The force is proportional to the square of the distance. And another simple example is that you have something which is connected by a spring, but it is also a pendulum in the small angle approximation. So if you take a pendulum, a three-dimensional pendulum, and you let it move not in the plane, let the bob move not in the plane, it is easy to show that the trajectory is again an ellipsis, but now with the center of the force in the middle of the ellipsis. So here is on the focus, and here is in the center. In this case, F is minus some times the distance. So this is power 1 and this power minus 2. Now, Bertrand theorem says that all other powers, which are not 1 or minus 2, give origin to. So let me put this here. So F is proportional to d to the minus 2, and here proportional, negative proportional to d. And so now the Bertrand theorem says that if you have any other power, so F is proportional to d to some power alpha, which is different from minus 2 or 1, the trajectory is not closed, but processes around something, so around a point which is not the center of force. And so this is interesting historically because when Mercury was analyzed, the trajectory of the planet Mercury was analyzed in detail, it was seen that the perihelium of Mercury was continuously moving. At first, this was, say, attributed to the influence of Venus, Earth, and Jupiter. But if you compute all influences of the other planets, you still have a processing of the perihelium. And so before Einstein came with his theory of relativity, showing that this is due to the curvature of the space-time, one suggestion was that maybe the force, the gravitational force, is not exactly 1/r², but maybe is some small power different from with small difference from 2. So what we can try to do is to do something similar to this, but instead having a sun, having a planet, and having a slider that can change the power of the force. Okay, this is not so difficult, not so different from this. So let's start with the new one. And again, we have a setup button, setup. Okay. And in the setup, I can say create a sun, create turtles one, set shape disk, no disk, circle, set color yellow, and so this creates my sun. And then I want to create a planet. Maybe I can stay clear all. Create a planet, but since then I want to move only the planet, it is better to define a grid. Planets, planet, and we know that we need planets own x, y, vx, y. Then we also need some globals dt, set dt 0.01, and okay, we create planets one, set I can put it in the middle here, for instance, set x core max. So this word goes from 0 to max px core here. So I can set it max px core divided by 2. Not here. Here. Set y core 0. Set Vy something, Vy0, then we put it in a slider. Set Vx 0. And okay, set shape circle, set color green, color, again pen down. Maybe we can arrange for having buttons for tracing or not tracing. Again, since the planets can go outside my world and I don't want it to wrap vertically, I also define the x and y, and so set x core, set y core. Okay, so let me see. Now, clearly I said, but I didn't put my slider. Vy0. Let's start with something. So setup, maybe setup. Okay, so I have my sun, I have the Earth or the planet, and then I want to make a button go forever. And so to go, so I have to compute the force. So maybe here I write fx, fy. They could be just local variables, but I may, I don't know. So first I compute, I can advance the coordinates. Set x plus vx times dt. Set y plus vy times dt. Then I compute the forces. So I said that I want to have a slider here, alpha from -3 to 3, say. This is the power in my force field. So set fx, compute the distance. Let r sqrt of x squared plus y squared. So this is the distance of my planet. And so the force, clearly now I have to compute the force in modulus is r to the power alpha. But then I have also to orientate it towards my planets. So it is proportional to the versor. So let me come back to the blackboard. So I have the sun, my planet, and so this is the vector that goes from 0, 0 to xy. This is r, which is the square root of square plus square. And so I have to, the force should be directed in this way. So it is proportional to this vector. But if I divide this by this, I have the right versor with the -1. So fx is equal to, probably we have to scale some. So r to the power alpha times x divided by r, so it is to the power alpha -1, with a minus, and yes, and I hope, and yeah, I don't need this, and fy is this, and then I can set vx plus fx times dt, set vy plus fy times dt, and then like the other, if x is here in my field, if x greater than min py core and x less than max py core and y greater than mean, no, px core, mean py core, and y less than max py core. Set x core x, set y core y, or set xy is the same, x core, y core. And okay, then we can make an improvement on this. For the moment, let's see if this works. So setup, because these are globals, so set setup, something here wrong. To go, I missed some parentheses somewhere. Expect the closing parentheses here. This is the problem. The problem is that I cannot learn how to how this syntax works. Okay, now let me see. Now something still wrong here. Can't use go because it's turtle only. Again, I have used some variables. To go, clearly. To go, ask balls to do all of this. Okay, so it is clear. These are variables of a ball, and I cannot manipulate directly the variables of something. I have to ask this to do something. It is essentially like balls, planets, not balls, planets. Okay, setup, go, something not really working. Let's investigate what happens. So if I go, probably dt is too small. No, it is x and y, which is too big. So let me start from 0, and let me eliminate the forever here so that I can control the steps. So planet 1, inspect, so setup, okay, when I have to inspect after having done setup. Go, okay, this is Vx, something negative, Vi, the x8, okay. Go, I don't understand why I don't see it moving now. Probably it is not so big displacement, but I should see it moving a bit. Now, why? It seems not to move at all. Okay, now y is too big, but since it has a pen down, this is very strange. To go ask planet, set x, set y, r, alpha, let's put it -2. Clear all, create start or clear planets one. No, I still don't understand. So I may save it in the shared directory so that you can have an idea. Maybe you are able to understand something. Set up, inspect planet one. I have a clearly working. So essentially, it becomes quickly extremely large. So let's try with the initial velocity extremely small. I still don't see. So these are not numbers which are too strange, but still I don't see it moving, which is okay, I know why. Because I have not set here x core equal, now what this is? If x greater than this condition is wrong for some reason. And because it never is never executed. So if x greater than minus px core and x less than max px core and y greater than minus py core and y less than max, let's ask balls show this condition planets and show x less not greater than true. So set xy stupid. If I put when this condition is true, move to the same coordinates, clearly nothing happens. Yes, exactly. Thanks, Mauro. So now, okay, something which is not what I expected, but something is working. So go. Okay. We can increase a bit the initial velocity. Okay. Clearly, this is an approximate algorithm, which is accurate only to at a certain point. So better use, say, DT small or use a more advanced integrating system. But you see that now the system is working. The sun is. Well, I expect that it is the focus of my planet. Then I can check alpha equal to 1. Set up, go. Maybe I can increase this. Also. Okay, so this time the trajectory, maybe this can be increased also to some other value. The trajectory is essentially an ellipse with the sun, the center of force in the middle. Then if I change even a bit my exponent, the trajectory starts to proceed, also starting from this, up too much. too much means that I have to go in the other direction. And so now if I change the exponent, you see that the trajectory started to proceed in one way or in the other. And this is essentially the Bertrand theorem, which is not easy at all to be proved. But can be so quickly illustrated by some simulation. Okay. And so now, for instance, I can, so first of all, is it all clear how it works?
Prof, una domanda banale. Perché prima non andava, dava un problema sulla parentesi dove c'è alfa meno 1?
Here, because
Yes, here.
if I write it
Why?
like this, it is not -1. It is not the same as -1. This is an operator, and this is the argument of the operator.
Ah, ok.
And here I should have written in this way.
Ok.
Unfortunately, NetLogo uses spaces for discriminating the operators. They did this in order to keep the language simple for the interpreter. I mean, because in other languages like say C, Java, JavaScript, when the compiler sees this, it has to decide if this is a constant or it is minus and a constant, so an operator and a constant. While for NetLogo, the compiler has not to decide because this is the operator and this is a constant.
Okay.
So they made the things simpler for the interpreter and more difficult for humans.
Okay, thanks.
Okay, so this is an example of, say, a more complex motion. Clearly, you can generalize this. For instance, if you want, I don't know if you have read the problem of the three bodies. There is a science fiction novel by its Chinese author Liu Xin. Let me see. Problem of three bodies. Three body problems novel. This maybe this one. Okay, so if you read this novel, the problem is of a planet which is in a system like the Alpha system, in which you have three stars, and so clearly the system can experience several say problems because sometimes it has three suns in the in the day, and sometimes it has say periods without any stars. Clearly, in general, the trajectory is chaotic, so in general, one of these four bodies is expulsed in the system. But if you want to play with this, you can modify a problem like this in order to have other planets. So I think that we have played too much with physics, so maybe we can go to some other problems. For instance, I don't know. We may try to model prey and predators if you want, or chemical reactions, or some other some other problem. Let me see. If
me personally, I was interested in the model with the network creation. I think I sent an email to you about it.
Okay.
But prey and predators is fine for me also.
Okay, no, we can, let's try to play with the networks. So, in NetLogo, there is a possibility of joining two things with a link. For instance, I can here, when I create a planet, I can also say create link with one of let's say that I have another breed. For instance, here is sun, and I call this sun. One of suns. So in this way, in this case, I have say an easy way of drawing a line from one object to another one. It is clear. Links are objects like others. So a link can be inspected. It can say have some property. It can be oriented. If you want oriented, is create a link to. So if you do this, you see that now the links has an arrow. Links can have their shape, so you can change the shape of an arrow. For instance, you can have some curviness. You can have 3 pieces, so three lines essentially. So for instance, you can have some different shapes. You can have the indicator, so you may say, for instance, have this more colored or something like this. And they have name, so I don't know why I cannot change the name, but I had to duplicate. Okay, this is just for showing. So now you see that I have a different way of indicating my link. And so you can use these links also, first of all, to arrange your objects in a certain way. So for instance, let's try with a new problem. No, I don't want to save this. So let's try with n bodies, n particles. Each of them has a certain number of connections at random for the moment. And I want to say arrange, so create, when I click setup, I want to create a certain number of bolts, say, ask each of them to connect to a certain number of other bolts, and then maybe I can infect one of them and see if things spreads or not. Okay, so to set up, clear all, and create turtles n, set say shape circle, set color white, and that's all. White is without this, and so okay, clearly set xy random x core random y core, and so now according to how many balls I have, they are set up in a certain way. Then I now ask them, turtles, quindi I'm asking all of turtles, set links with, set links, something not, I have to check on the dictionary as usual. So here is the dictionaries, links, set, no, create a link, quindi create, my set is create links with n of k other turtles. This is not exact, but for the moment, let's start with this. So first of all, let's see what happens. Let's put say 1. Set up. You see that each turtle has at least one link, because each of them has established a link with another one, but it can be target of more links. So in general, show count links should be the double of show. Okay, each link counts on, it connects 2 but counts for 1, so we have 50 links that each one of them connecting 2 turtles. Now, okay, for the moment we can stay with this. It may happen that I have more than one link. Let me put this not with wrapping so that it is simpler to see. So for instance, if I have 2, no, too much. If I have, say, 10 or 8 turtles, or maybe less, 6 turtles, and I ask to set up each of them 3 links, clearly there are some double links here. So if I want to avoid the double links, I have to repeat this several times, asking to set up links with other turtles not already connected. So for the moment, let's examine this. Turtles is the set, the agent set of all turtles. Other is the agent set of all turtles which are different from the one who is performing the computation. N of takes a number and an agent set and returns a random sampling of k items from this set. Remember that this is essentially a language for dealing with the sets and lists. Okay, so for the moment, let's start with this. Then I can ask one of turtles set color red, And then I may perform, say, a simple percolation process, which is to go ask turtles if the idea is that I can ask each turtle to give the list of connected turtles. If I remember how to do this. In this moment, okay, it should be this one. This no, if this is a test for testing if two turtles are connected. No, should be this one, out link neighbors. Quindi it reports the agency of all turtles that have a directed or undirected link with the caller. So if quindi any out link neighbors, okay, so this is the set of all neighbors, but I want to select so from them all that have a color equal red. So oops. For any turtle, this gives the list, the agent set of all neighbors which are connected by a link. With the keyword with, I select all, so the agent set of them that has color equal to red. With any, I test if this agent set is empty or not. If it is not empty, I become red again, red also. Set color red. Okay. So when I press go, all connected turtles are colored by red. And so I can test if the network is connected or not, for instance, by repeating this several times and checking if all turtles are became red or any of them are still white. Okay, so this way is this is a way of say making a process of a network. Then I can also to use a way of arranging the turtle in a set by making the links in this set as if they were springs and turtles are repelling each other. No? For instance, let me, for instance, copy this one here. So you see that essentially the springs behaves if they were links behaves if they were random, and so well, there are several ways of arranging. This is just one. And essentially here I can change, because this is the spring constant, but this is the spring length. So if I put this smaller, they are arranged, but this time in using springs with a certain rest length. And so you see that using this maybe several times, I can so maybe have a more interesting display. So because clearly with network it is not always clear how to display the network. So, and this is also the attraction, and this is the repulsion, so one can play with these values. For instance, if I put this here, a smaller value, you see that they are no more repelled like before, so they stay closer. And so let me put a button here saying reshape, so that I can do reshape. I put this. And I can save this as network infection. Okay, so with this I can visualize the network processing, and then if I repeat enough, maybe I can do this forever. Okay, so now I can see better that the system actually is divided into two unconnected networks, and maybe we can try with a larger number. Say setup. Clearly it becomes hard to see the differences, but you see that actually we have two or probably three different networks. So maybe we can do something like this. Setup is okay. So instead of choosing a red ball here, I can make a button like detect component. Okay, so to this I put here. So ask one of turtles with color equal to white, set color red, and then let changed 0 no set, but I cannot use always. Okay, then I change color. So ask turtles if any, ask turtles with color equal to white, if any color red, set color red, and set changed +1. Okay, so I can do while I want to repeat this until there is no more changed. So let's start with changes equal 1. While changed greater than 0, set changed 0, and then I compute. So let me start. Then I have to, something is wrong here. What is wrong? Detect, yeah, clearly. Detect component. Set up. Okay, so it seems to work. Now I have, say, a component. And now I want to change the color of this so that I can use the red to detect another component. So ask turtles with color equal to red, set color one of colors. I hope it is not red again. One of not one of colors, random color should be I don't remember. There is a way of asking maybe it's a one of base colors. No, because I have to do it. Let my color one of base color, my colors, otherwise they take a different color. Okay, so now at least if I don't have the clearly I have to say remove red from this. I can do this, for instance, having a removing red from this base color, and this is the last thing that I do. If I remember how to remove something from a list, let me look it. List, remove item list. Okay, so remove red from one of remove red base colors. I hope it works. Okay. Clearly, this is not okay. Set up. Clearly, I should have, say, maybe more things, but they tend to be all connected. So maybe I could use a network with the probability of establishing a link so that I don't have always almost all them connected. But this is the basic idea. Questions? Okay, if no questions, I hope that you appreciated it. I still invite you to submit the problems as you did, so that we can examine them together. Clearly, I should say maybe dedicate one lesson to studying the syntax of this language, but it is a bit boring. So let me know what you prefer to do. In the meanwhile, I can stop the registration.